Super nice to see you all here. So I'm Albin. I work as a TSE at SmartEye, previously as a data engineer at Cytic, as you may know. And today I will bring into the topic of detecting impairment before it turns into an accident. My journey started with Cytic by planning, executing and developing our model for impairment, and then especially alcohol impairment. What we focused on now and later, and I will show you that in the presentation, was also drugs. And we were aiming to cannabis and then more specific drug uses. Do I have a... Oh, here it is. So I think this is the big next step in road safety. More than 20% of all fatalities in US currently are by drugs and alcohol. That's 8,000 lives each year that gets lost. That's something we have to do something about. And when we started this 3 years ago, we wanted to see what is impairment. So impairment can be divided into transient, which is something that is temporary, that, for example, a phone usage or, for example, short distraction. And then non-transient, which is fatigue, which is then drowsiness and sleepiness, but also non-fatigue, which is something that I want to talk about today, which is alcohol and drugs. So we started this 3 years ago. We asked ourselves, what is impairment? So we gave our colleagues, 25 colleagues, 50 clips of people that were impaired and sober, and wanted to see, can they see the difference between impairment and not? The results were shockingly bad. They guessed slightly better than random at 59%, and that made us ask ourselves, what did they think that impairment was? Was it flush in their eyes? Was it something else, or was it a head movement? So today, you're measuring impairment. You connect it almost 100% with BAC. Impairment, you think of BAC, okay, here in Detroit, for example, it's 0.08. And then you think, okay, impairment should be at 0.08. In Sweden, it's 0.02, which is very low compared to here. And I think that you can't even measure impairment at that level. But today you use the breathalyzers mainly in commercial vehicles, but you can also use it for example, the police officers. They do it on Swedish roads. They are expensive, they require extra hardware, they require calibration, and they are intrusive for the driver because they have to use the device somehow. So we want to find a new method here. The way BAC works, it's dependent on weight, length, and genetics. I have, for example, my friend Johan and Vera. They were at an event 2 years ago when we started developing this. Vera, she drank 3 beers and 2 glasses of wine. She was just slightly impaired. She's 5'2", 130 pounds, and then Johan, he drank 9 beers, 2 glasses of wine, and then 2 shots. He was heavily impaired, could barely walk, and could definitely not drive a car. But he just blew 0.05 because of the BAC is so fluctuating in the genetics and length and so on. So in Detroit, for example, he would still be able to drive the car home for the bar. Rather, he was super impaired, but Vera would have been charged for drunk driving. And I think that's the way we need to look at this. We need to find a new solution for looking at impairment. Impairment shouldn't be directly connected to BAC. BAC works well at understanding at the populational level. But at the individual level, as I said with Vera and Johan, it breaks down. At the individual level for driving, it's exactly when you want to measure impairment. So we need to find a new way of solving this problem. How do we define impairment individually in cars? To ask us this, when does sober end and drunk begin? Where's the line? Where can you draw this line? Where's the threshold? I think most of you who drink here, it comes gradually, it comes slowly. It's not a line, it's not a threshold. You can't say now you're drunk and now you're not drunk. But in the research, we see that the fatality risk, it goes up with BAC. So this is at the populational level. This is over a large group of people. For example, at 0.85, this is European scale I see now, so 0.05 for you Americans, the risk is almost 4 times as likely that you will crash. At 1 promille or 0.1%, that is 9 times as likely. And 0.15, that is 27 times as likely. So the risk the risk of fatalities increases as the BAC rises. It doesn't measure impairment at the individual level, but it can tell us something about impairment at the populational level. So BAC, it correlates with impairment at populational level. Therefore, a huge data set is required to actually capture this human behavior at the individual level. So then we now will do some benchmark here in the audience. You will see two clips here. One is drunk, super drunk, like 0, 1, 2, and one is sober. I'll play the first one, left one. And the right one. So, who do you think is impaired here? We go from the left. Raise your hand if you think that one is impaired. Okay, that's about 50%, I would say, like maybe 50, 60%. Here are the results. So it's very, very hard to tell from this that someone is impaired or not. It's super hard. And that's why it's so important to measure over time. I like to think about it that a sober driver, he has 100% of clarity. An impaired driver have moments of these clarities. And sober driver, he drives good judgment, good speed control, good brake control. An impaired driver can shift in and out of this. You can see it on the head movement, you can see it in the pupils and so on. So the more impaired the person is, and we see this when we do huge amount of collections, the fewer and shorter these moments become. So monitoring over time is a critical thing to actually absorb these fluctuations in the clarity. And to also go beyond this, we don't want to measure. I think we should stay away from the legal limit on the aspect of impairment. We don't want to measure exactly, you're at 0.08. We want to measure if you're fit to drive the vehicle. So that's the important thing here, to save lives. And we should measure the impairment for individual driving. How do we then detect this? There are multiple methods today: breathalyzers, pattern analysis, heart rate sensors, and so on. But most of these have trade-offs. They are either introducing a whole new system or a new integration of software. They're expensive. They require hardware. They require calibration. Or they are just intrusive for the driver to actually understand and see, to actually measure this BAC level or the impairment. So the ideal solution here, it's something that is non-intrusive, low cost, and just is already installed in this vehicle, and that's a camera. It already exists in most newly produced vehicles. And that's what we've developed, a DMS system that can actually detect impairment. It's in your vehicle today, and that is what makes a difference. There are no new hardware requirements, there are no calibrations, no contact needed. Every modern vehicle has a camera that also then has a DMS system, or mostly new produced vehicles in Europe at least. And the most practical, the most scalable solution is already here. And research confirms that this is actually measurable. So if you look at the research, the gaze pupils, the head pose, and the gaze pattern, it's actually measurable from a research perspective. There are validated physiological responses that actually can see this. For example, glance rate, it goes down. Glance duration, it goes up over the BAC. But this is also at the populational level. So we still need to have a large data set for this. And that's the data problem. So how do we collect something, or how do we detect something that you can't really collect data on? I mean, our real environment here, we want to detect impairment on real roads. That's what we want to do. But we can't just send out drunk drivers and collect data, and as we would do with phoning or something like that. So we need to find a solution here. And all models or systems that you want to develop need some supervisory signal. In our case, I think what we can use is BAC at the populational level. So we need a huge amount of data, and we can combine that with cognitive tests. We can combine it with ratings from school drivers that collects this data when we have the safety driver with the participant in the car. So we have several inputs for this system. And I like to think about it as 6 domains. You have simulator data, sober and impaired. You have test track data, sober and impaired. And then you have real roads, sober and impaired. I mean, we can collect the sober data on real roads, of course. But it's the alcohol impairment on real roads that you actually want to collect. That's something that you want to predict, but it's the thing that is hard. For a simulator, for example, the environment is controlled, but there are no vehicle dynamics, there are no actual real road things that happen. If on a test track there is a real vehicle, there are vehicle dynamics, but there are no actual traffic simulation, or there are actually no there is nothing that happens for the driver that is real on the road. So we want to be in the middle between test track and real roads. Why isn't then simulator enough? I mean, in our research, we see a huge difference between the behavior for the individual in the vehicle, for example, gaze movement and head movement, between the simulator and real car. So why wouldn't that differ between impaired driving as well? So then we need to collect real data from naturalistic driving. This is all about human behavior. We can't simulate this. It's something that is, just for looking at the impairment for Johan and Vera, as I told you before, it's so different for impairment. So we need really human data, human behaviors on real track. And this is what we have built. Realistic conditions that closely reflect real-world data driving. Participants drive real vehicles with simulated traffic that we do. For example, roundabouts where we put cars and then we do opposing traffic. We have maximum naturalistic driving with maximum participant safety by control drivers always doing dual commands. Developed in collaboration with our research partners that work at traffic schools and so on to really simulate the real environment, which allows the driver to be able to mimic this real environment at the test track level. And all sessions are health checked for the participants, are ethically approved. And for you tier 1s and OEMs here, you can come to our test track, you can validate our models, you can collect the data for your validation purposes. You can see how we collect it. And for third-party users here, come and see how we do it. For real, this is working. So, I mean, we have the system, it's working. And what we've built is the world's largest data set of naturalistic driving. There's a complete framework of test track, the safety design, ethical approval, and there's a validated model that you can come and see. It's proven in naturalistic condition. It runs entirely on your existing DMS. It's just a small software package on top of your, or next to your drowsiness and distraction models, and it integrates in the same way. So there's no added hardware, no added calibration, and there's a low cost on this. So now we have the system. We have the signal. What should we do then? What's the intervention we should do when we see that the driver is actually being impaired? What should the OEM do? Most people talk about these false positives, and I think it's a valid topic. How do we introduce this to the market? Because the market now, they are afraid of, okay, there is a sober driver, he's being labeled as impaired. I think a warning is ineffective. A drunk driver, of course, knows I'm drunk. He knows that. He's compared to, for example, a drowsy driver that maybe don't know he's drowsy yet. The car knows that he's unfit to drive the vehicle, but compared to a drunk driver, he knows. So a warning wouldn't be suitable, and it would be ineffective in this sense. So then the severity of the intervention should come from how impaired the person is, or how certain we are on the impairment. For example, just introducing lane keeping, or more ADAS feature, more distance to other vehicles. This is something that is not intrusive for the driver. This is maybe something that you even notice when you're a driver. And I think this is the step how we should introduce it to the market, so people accept this type of behavior, or this detection systems. But what should we do in 5 years then? We take this the next step. Today we ask ourselves, what should we prevent an impaired driver from doing? In 5 years, I think we should reverse the question with level 3 and level 4 and so on. Maybe in 10 years, what should the driver be able to do with the car? I mean, we are trying to minimize and saving real lives. 8,000 lives are lost only in US. That's not the world, that's only in US. Then we should ask ourselves, what should the impaired driver be able to do? So the level 3 and 4 autonomy of the driving then reverses the question and reframes the impairment detection as an access control question. So now we're also extending this beyond alcohol and going into drug and other substance-based impairment. And I want to finalize this speech with something that the goal is impact here. There are people dying every year, and we have had so many good discussions this event with Matt. They are talking a lot about it. There are real victims, there are real lives that are lost each day. Is it 36? 32? Yeah, 32 lives each year, only in US that are lost due to these systems. So the goal should be impact, not perfection. You don't need a perfect system to begin with. You need a system that is present and is doing an impact for the car. It's in the car now. And if we can get just 10% next year and we can get 50% in 5 years, that is impact. That's 4,000 lives each year that we can save only by introducing a system like this. So thank you for your time and listening. And I want to summarize this by it's about fit to drive, not legal to drive, as we told. As we said, human behavior cannot be simulated. We need real naturalistic driving, and the solution is already in your car. The DMS can be used to detect this. It's present now. So thank you so much. Come to our booth and talk if you want to go deep in these discussions. Thank you so much.
Okay. Anybody have questions for Albin?
Good morning, Bud Zauk, KA Technologies. 2 points, actually, 2 things I want to ask about is, the first one is, when you were running your studies, have you considered the impact of pharmacokinetics of ethanol in the human body, so absorption phase versus elimination phase? Absorption phase has a different impact on the body, on pupils and everything, versus elimination phase. So it's important to consider both, because in the absorption phase, you're going to have less impact versus elimination phase.
Yes, and we do this. We do increasing and decreasing phase, and we see a difference. And we also see, compared to drowsiness driving, and I think that's the important thing. You can't fuse this signal, because there are some overlap between drowsiness and alcohol impairment. But the thing here is that you need to separate the intervention from them, as we talked about with the drowsiness. That is something that you maybe don't know as a driver that you are, but alcohol you do. So we need, in the increasing phase, we see no overlap between drowsiness and impairment. But for the decreasing phase, we see some overlap, but that is also natural, because in the decreasing phase, with alcohol impairment, you are slowing down the cognitive movements and the physical abilities. So yeah, we do these collections, we've done it. So we often go from sober to 0.08 up to 1.2 and then down again. So we do that for 4 hours and 2 more drives. So we often do 5 drives when we do these collections.
Okay, and you say you do it over 4 hours? Have you done extended 7-8 hours studies?
Yeah, so the total is 8 hours.
Okay.
But the decreasing phase is 4 hours. Okay. So we don't go down to, what we haven't done in that sense is that we go down from like a hangover. That we haven't done. But going down for decreasing back levels, we have done that. And I think there's that data is very important as well, and we want to collect the hangover data as well, but try me. I've tried that. Yep. I've tried to get my friends into, when we did all these simulator tests, I tried to, can you come tomorrow and be hangover and drive? And they didn't come. So, yeah.
My second comment is, how do you intend to handle, BAC laws are worldwide. They are laws. The pharmacokinetics of ethanol, again, has been studied over 50 years using BAC and the process of elimination and understanding human body. I would recommend not to discount that completely, because there are laws across every country that has limitations of drinking. Yes, you said Sweden 0.02, US is 0.08, most of Europe is between 0.04 and 0.05. So somehow you have to come up with a correlation that says, you are now breaking the law. How do you intend to do that, I guess, is my question.
That's a really good question. I think in our discussions, we try to separate the system from legal aspects. What we do when we classify someone is that we are super good, and we can show you, if you're very interested in the KPIs and so on, we can book a private meeting and show you. But we are super good at sober, and we're super good above 0.08. In between this zone where the most legal limits exists, we have something which we call possibly impaired. We see some, as I told you with the clarity thing, we see some signals that shows impairment, and there are some signals that show sober driving. So I think that clause is something that we use for that purpose, but it's a really good question how you would like to implement that, and I think that's something we have to figure out when someone actually, I mean, now we're going out to production 2028 with Japanese OEM to implement this on the market, but I think that has to be something that comes gradually, and maybe you can implement that, say that now you're breaking the law, or now you're acting as you're driving impaired, but then there's the negative thing with that would be that if you get a false positive, then you're saying to that driver that you're driving drunk, and I think that's a problem. So I think the other interventions as a beginning, just for introduction to the market to make the system mature, is something that we will begin with. Hope that answered your question, somehow. Yeah.
Anybody else? Any other questions? Yep.
I think you're onto something, disassociating from the legal definition and trying to redefine what is impairment. Thinking on the user adoption side, especially here in America, we've got strong pushback. We don't want these big brother monitoring devices. So do you care to opine on what would be maybe a more synergistic way for the OEM to react when your system is giving this level of impairment advice, I guess, to the vehicle? What should the vehicle do with that to where the end user doesn't think of this as a big brother device, but more as a safety device that's helping improve lives?
Yeah. So I think we have had very good discussions with MAD. I mean, especially in the US, because I'm coming from Europe, we already have, in all commercial vehicles, we have these breathalyzers. So I think there's a whole other acceptance to the market. But for example, in the US, we talked about it, and that's more about, then maybe you have to go it from the other perspective, make the customers want it. For example, parents and insurance companies, that they push it from their side, and then the regulations can come, because of course there will have some regulation or some law that has to be present for this to be able to work in the US as a concept. But for the intervention side, I really think what I said there before, maybe I can go back to that one. Oh, okay. That the intervention should be like on the severity level of how much you know that the person is impaired. So, for example, advanced lane keeping, or distance to other vehicles, or slower acceleration speeds, and so on. Things that actually limits the car from being driven unsafely. When I see people drive drunk, I mean, I've seen very many people drive drunk in real cars. I don't see them as a bad driver. I see them as a bad judgment. I would see the judgment is the thing that you would have to be up on the high ones if you're not able to drive the car. It's more in the lower ones you're dangerous, because then you can drive the car, but you have super bad judgment. So I think that's something like making just the car very, very safe, and introducing it as a safe system that's not targeting the sober drivers, and they wouldn't notice it in that sense. I think that's the implementation of it, if that answers your question.
Okay, one more. Anybody? We're just about at time. No? Okay. All right. Thank you very much, Albin, for all that you're doing, and Smart Eye, and thanks for being here. Yeah.
Thank you so
thanks
much
your
for listening.
presentation.
Hope you took away something.